All right, so in our previous video, we talked about finding the area using polar curves, and now we're going to talk about finding arc length using polar curves. We have a formula for arc length. The length of an arc from alpha to beta is equal to the square root of f of theta squared plus f prime of theta squared d theta. Okay, I'm going to give that as dx over d theta plus dy over d theta, or r squared plus dr over d theta. Whatever, it doesn't matter how you think of it, it just means that you know what's really going on here. So let's actually find the length of the cardioid, 1 plus sine theta. Okay, well, what would that look like, first of all? 1 plus sine theta would look something like this. To sneeze. Sorry, students. And we want to find our x and our y so that we can find dy, excuse me, and dx. So x is equal to r cosine theta. You remember that. So in this case, x is going to be equal to 1 plus sine theta cosine theta, which of course equals cosine theta plus sine theta cosine theta. Well, what's our y value? Y is equal to r sine theta. So y is going to be equal to 1 plus sine theta times sine theta. So that equals sine theta plus sine squared theta. All right. So now we can actually find our dy, or our dx d theta and dy d theta. So dx d theta is going to be equal to negative sine theta plus cosine theta, cosine squared theta plus, minus sine squared minus sine squared theta. Okay. And then dy d theta is going to be equal to cosine theta plus 2 sine theta cosine theta. Okay, so now what's our arc length? Well, our arc length is going to be equal to the integral from, this is going to go from 0 to 2 pi, that's a pretty easy one because we don't have to go that far, of the square root of negative sine theta plus cosine squared theta minus sine squared theta plus, so long to write, cosine theta plus 2 sine theta cosine theta d theta. And this equals, I'm going to put it in my calculator, blah, 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 blah. This equals 8. Okay, let's do another one. We want to find the arc length of the cardioid of r equals 2 minus 2 cosine theta. Well, let's do this. This time, we're going to use dr d theta. Let's do that. So, what does this look like? 1, 2, 3, 4. We've got a cardioid that looks something like this, right? So our arc length is going to be equal to that alpha to beta of the square root of r squared plus dr over d theta quantity squared d theta, which in this case is going to be equal to, well, we know since we're finding the entire cardioid, we're going from 0 to 2 pi of the square root of, don't forget that square root, that's super important, 2 minus 2 cosine theta squared plus, well, our r is just going to be, this is going to be dr d theta, oops, this is what I want to write, is going to equal 2 sine theta, right? So plus 2 sine theta quantity squared d theta. And if I want, I can expand this out from 0 to 2 pi, square root of 4 sine squared theta plus 4 cosine squared theta minus 8 cosine theta plus 4 d theta, which once I enter it in my calculator is equal to 16. Woohoo! Very exciting. Okay, let's do another one. One more. We want to find the length of the polar curve. R equals the square root of 1 plus cosine of 2 theta for negative pi over 2 is less than or equal to theta is less than or equal to pi over 2. Okay, well, we can do that. First, let's find r prime. So r prime is equal to 1/2 times 1 plus cosine 2 theta to the negative 1/2. So I took the derivative of that. Then I have to take the derivative of what's inside. A negative sine of 2 theta. Then I have to take the derivative of what's inside there, and so that's times 2. So these are going to cancel out. So I'm going to get negative sine of 2 theta over 1 plus, the square root of 1 plus cosine 2 theta. Right? That's r prime. So our arc length is equal to, remember we're going from negative pi over 2 to pi over 2, of the square root of 1 plus cosine 2 theta plus negative sine 2 theta over the square root of 1 plus cosine 2 theta squared d theta. And once I put that in my calculator, I get that my arc length is approximately 4.443. Okay, if you have questions, leave them in the comments. Hopefully this makes sense. I look forward to, I really hope seeing you soon. And I'll talk to you later. Bye.